You're welcome again. I remain your tutor, Mr. Jude Anadozie. Today we'll be looking at a different topic: energy quantization. Energy quantization. According to quantum theories provided by Max Planck, heat or electromagnetic radiation is emitted in fixed, discrete, or separate amounts known as what? Quanta. Known as quanta. Uh, what that means is this. Let's go down a little bit to chemistry. In chemistry, let's take sodium atom. Sodium atom, we are made to know that it has what? Two electrons in the first shell. Second shell, we have like eight. And the third shell, it has one atom, sodium. Now, let's assume this atom acquire energy from a source. That these electrons in it now have to now jump from one energy level to another. This first object takes it as an energy level, second one energy level, third energy level. It cannot jump and remain in this middle. For it to move, it has to move to this part direct, and this one to move, that has to move to this part direct. And when this electron now here, or any of the electron, is breaking out, that energy it requires, that enough energy is required to break out and not to return here, you know as what? Ionization energy. So the energy this man needs to jump to this part is fixed. So what it means is that if it doesn't acquire that amount of energy, it will remain in its energy level. So it has to acquire that amount of energy for it to what? Move from here to a what? Higher energy level. And when it moves from one energy level to another and trying to return back, it has to give out that energy. Just like you stretch a rubber band. You stretch a rubber band. When you leave it, that energy you gave to it for it to stretch will be what? Give it out. And that energy, coming to energy quantization, is denoted by what? Planck constant multiplied by what? Frequency. Planck constant. Planck is a constant which is approximately what? 6 point what? 6 approximately times 10 raised by what? Minus what? 34. Times 10 raised by what? Minus what? 34 what? Joule what? Second. Why is it joule second? Why is it what? Joule second. These are the things I love in my tutorial. I will break it down for you. If you make Planck constant here the subject of the formula, make H the subject of the formula, what are we going to have? This is what we are going to have. Dividing both sides by F, right? When you divide both sides by F, you have H equals to what? Energy over what? Frequency. And energy is measured in what? You know it. It's measured in what? Joules, yes? Correct? You are correct. Frequency is measured in hertz. And another unit of frequency apart from hertz is what? Per second. Remember, frequency is inversely proportional to period. So frequency is same as what? Per second. 1 over what? Second. Which gives us what? Joule divided by 1 over what? Second. Which gives us what? Joule what? Second. When it changes to what? Multiplication. Then here become what? S over what? 1. This is how we obtain what? That what? That formula that we have there. So this is Planck constant H. Whenever you're given a question, it could be 6.63, 6.67, they may attach, they make this word 2 decimal, depending on the examiner, but just roughly around this. Then what you discover here is this: energy is directly proportional to frequency. What does that mean? It means that the higher the energy level, the higher the frequency. What did I just say? The higher the energy level, for this man to jump from here to this part, to move from here to here, it needs higher what? Frequency. It needs what? Higher what? Frequency. Then what else are you expected to note here? You expected, I hope you have jotted this down. Frequency, velocity is what? Frequency times what? Lambda. Lambda representing what? The wavelength. The wave what? Length. The wavelength. And here, due to we are talking about electromagnetic radiation here, talk about radiation here, we use what? C to denote our what? Speed of light. We use C here. So making air frequency is subject to the formula here. We are having what? Speed, velocity over what? Lambda. So bringing this into this formula, what we are going to have? We have what? Planck constant multiplied by speed of light over what? Lambda. What does this tell you? These two are constants. Only these what can vary. So that means energy level is inversely proportional to what? Wavelength. Recall, I said previously that energy level is directly proportional to what? Frequency. And now, because that energy level is inversely proportional to what? Wavelength. So an element could be what? In ground state, very close to what? Nucleus. For it to move from the ground state to a higher state, to calculate the energy, so is the new energy level minus the former energy level, which will give us our what? Our E, our energy. It's as simple as that. We're going to look at some questions and see how easy these formulas are in a what? In when it comes to what? Application. This is just what you just need. And one other thing you need to note is this: in energy quantization, if this be the ground states and this is first energy level, as it moves up, the distance between them what? Closes until you acquire the what? Ionization energy, where the energy what? Where the electron what? Breaks out of the what? Atom, and what? And that it goes. As it moves up, this gap what? Reduces. Remember, energy level is inversely proportional to what? Wavelength. So if you are given an energy level, third energy level, second energy level, or whatsoever, and you are asked to calculate the energy required at that state, can go ahead. E equals what? 1 over what? N squared. Everything multiplied by R. R being a what? R being a what? A constant. R being a what? Constant. R being a what? Constant. And for now, this is just what you need on this until when we proceed to the what? Let's see. This is just all you need. Energy equals to Planck constant as frequency, and frequency is taken as what? The velocity of light over lambda, which is wavelength. Bringing it up there, give me what? Planck constant times speed of light over what? Lambda. and En minus E naught give you what? Energy. And also this, and so I've told you that energy is a proportional to frequency, and if a proportional show what? Lambda. You've also known this. And I told you also that as the energy level increases, the gap here is higher than the gap here. As it moves up, as the energy level increases, this gap closes up, so the energy reduces as it goes higher. As it what? Goes what? Higher, until it gets to what? The ionization energy, where the element what? Breaks out. So you need to note all this, note all this, note all this. Um, yes, that is that for now. Remember, your energy is measured in joules. Frequency is same as per second, which is hertz. And Planck constant is what? Joule second. And you can see giving electron volt, which is not which is not an issue. So from here, we will look at questions under this. After answering questions under this, we move forward towards how work function comes into play here.